Welcome back, Generals, to another Let's Fix Generals at Zero to make the best game ever. Good. So, yeah, we need to find a solution for the height map. I still don't know what to do with it. Now there's maybe there could be a similar tactic as to what we did with, I think, the map border or something, where we say if the pitch is too, well, like we could lock. What I would like to see is what actually happens if we run the original code for the height map and then we look at how accurate does this actually determine the origin position. Solo, yeah. Okay, so okay. Okay, also looks interesting. It does. Interesting. To me, this also looks like just an approximation, to be honest. I mean, what the hell is going on here? Huh. Okay, I think that looks pretty okay. Interesting that it goes to the center. It also acts in shitty ways. It's much more unstable. I can't tell if this is better than our cheaper approximation. It's also shitty in ways. But I think it does take the FOV into account. Look at that. Okay, I would say we give our approximation a bit more time and we try to tweak it and fine-tune it. Maybe we can combine it with some other sampling, which would dramatically increase its sampling. So we know that there is a problem. There is a problem when there is an area when we are on high elevation and we are looking down into deep low elevation, right? And the problem is that the the um, the distance that we can look towards is much further than if the terrain was just level. Because when the terrain goes down at the upper edge of the screen, then there's just much more distance that the view plane is looking to, right? And that's why then the height map area gets tighter, right? So it's a problem. Maybe so the original code is super complex because it first takes a sample, it tries to find the min height of the terrain over the current draw area, which is done here. So that's an expensive loop, right? So this guy is they are, how big were they? 129, right? So this one is 129 times 129 loop. How much iteration is that? $129. Well, it's over 10,000 times 129. 16,000. Holy shit! This function is this loop here is expensive. Wow, what is happening in here? It's just reading some data. Okay. This access is cheap, but like the amount of iterations, this loop here, this one is expensive. And I think this one is also expensive because this one does the recursive calls. But maybe it's not as expensive as this loop, actually. This loop might be just the most expensive thing of the whole algorithm. Possibly. Okay, so let's get back to this guy here. What if we got so we have a magic scale here. By the way, how does it behave if when we rotate the camera? Okay, actually, it behaves weirdly. Huh. Look at that. That behaves very strangely. Huh. By the way, we do have now a way to rotate in steps, right? That's cool. That's cool. what can we do? What can we do? I mean, it's, to me it looks like this one is really close, but it's missing that one ingredient to make it better, and I can't figure out what else we can mix into this to increase it. So the camera is looking down there. Edgeland scale. View deer. Terrain edgeland. What was this for? This plus this divided by 2. So it moves it half forward. There's a half forward. Half. So really? That's also weird. Why is it doing that? Puh. It's so buggy. So buggy. It's kind of good though that it goes up to the back even if the fourth is really extreme. So that's good, but yeah, there's so many other issues. Yeah. What happens if we don't shift? Well, then that's probably bad, right? So let's say we did tier 0. Yeah. Okay, why is it compiling everything now? What is this? Skirmish. Good, then let's say that. Okay, so this one would also go back. Yeah. If we do F9, that one looks actually pretty stable. Okay, so that's the default fourth. And there we have a problem. This approximation in combination with a larger draw area would be pretty good, actually. But yeah. So here we still have the issue in the corner. Yeah. How does it look when the camera is low? That looks bad. It's not made for this. You know what would be good? If we could draw the entire terrain, if we pitch down a little bit, so that if the camera pitch is default 37.5, this one here, that then it has this optimization enabled, with the draw area here of the terrain that you can see here. But if we look down, then it would then draw all terrain. This would make things easier, I would say. The question is, how do we get there? Draw entire terrain. I think if we change this on runtime, that probably won't work, right? Width. Word height map. Draw width X. New width. New width. Set draw arc. Draw width X. Yeah, we need to explore that. Height map updates. Update center. Updates. So now normal update, frame update. On frame update. Update center. Who's calling update center? Update terrain. Ah, this one. Right. Terrain. Update center. So I would like to make a hack here. So this origin min height, max height. Draw entire terrain. World height map. Draw with X. Draw with X. World height map. This. Oh, it didn't work. Isn't there somewhere world height map? Is it the... Let me restart the map. Restart game. It's calling in here. Stack, load map, terrain, world height map, terrain height map. Yeah. And that. So this is the entire draw area here. So set draw width. Set draw width. Set draw width. Map. Height map. Oh. The height map owns world height map. I see. So can we do this pointer and map? We can't. Update center. Okay, I'll put a breakpoint in there again. So, so I would like to see, there we go. So draw, where is it? Here, draw width. There we go. So what happens if we now change these values down here? This one and this one. My suspicion is it will crash now. Let's see. No, it doesn't crash, it just looks awful. Okay, interesting. Draw with X. Draw with X. Can we, maybe we first need to implement a function with which we can change this on runtime, right? But it already is changed on runtime here. Set draw org. Okay, let's get this one here. Get draw width. Aha. Init height data. Oversize terrain. Tiles to oversize. Sets the terrain oversize amount. Width, height. Times. Set the terrain oversize amount. Need full update. Oversize terrain. Oversize terrain. Okay, it looks like this function is already doing an increase of the draw area, doesn't it? Yeah, so it uses the normal height, which is 129 times 129 as a base. And then it adds 32 tiles. Times this. But interestingly, it has a cap here. It has a cap. Why? Why does it have a cap? So it's smaller files, so from 1 to 4. From 1 to 4. So 4 times 32, that is what? 128? 128. So that's double what it is originally. Double. 128. Is that large enough? It's pretty sizable, yeah. I don't know why it needs this limit though. Is this ever called, this function? There's another function here, amounts. Maximum number of terrain tiles rendered. Okay, we don't care. Oversized terrain. Do oversized terrain. Script, it's a script action. Okay, that's interesting. Oversized terrain. Oversize the terrain. Oversize the terrain. Num parameters 1. 0. Reset to normal. Okay, we can work with that. Okay. Oversize the terrain. Okay, I have troubles finding this function. There we go. Not needed with flat version. Shroud reset. Set rock. So I think the tactic here is that when we pitch down, then we should incrementally start oversizing. Yeah, I'm inclined to say that we remove this limit here. Yeah, and then we say we can also do another optimization here and say if if height equals draw width or ends and height equals draw height, then we are done here. Return. Okay, so don't think there's a need for limit. Yeah, so if it's large enough. Okay. Okay, this makes sense. Now we just need to find a way to then also do this, right? Update center. So in here, let's disable the original code here. And then we have this, and then we say camera position, ray direction. Camera location, camera pivot, camera pivot. I think for a test, we also calculate the pitch again, like what we did here in the previous change. Where was that? Let me find that very quick. Nope. Was somewhere here. Yeah, where we take this guy. So this is the delta, yeah. So we take this guy. So we have the camera origin. Where is it? Here, camera location. Let's do const vector 3 camera pos camera pros equals camera get position. Okay, and then we take this guy here, we say camera pitch, there will be camera pos, set, then we have const vector 3 view camera dir equals pivot camera pivot minus camera pos. Okay, it somehow doesn't work. Why not? Vector 3. Of course. Okay, there we go. Camera dir, and then this will be camera dir length. Do we not need to normalize it? No. Apparently not. No. Good, so this should be the camera pitch, and then we say, just for test, if camera pitch is larger, 37.5, let's say 30, let's say degree to red f 37 0 f, then we do oversize wasn't there oversize terrain? Yeah, oversize terrain tiles to oversize. Let's do 1 here in our test. Now here we do 0, else else we do 1. Okay. So now if we pitch down, it should oversize the terrain. Let's go a bit higher. Let's go with 4. Okay. Okay, I just want to see if it works. This doesn't make any sense yet, but I just want to see if it actually works or not. Right. So if we pitch down now below the default pitch, then it should oversize terrain. Okay, let's sell this here. Good, so. Huh. It seems to work. Yeah. There's some weird. I don't know why it happens at such a low pitch, though. Let me put a breakpoint here. Did I take the correct pitch here? Let me see. Target pos minus source pos delta. That's what we did here as well. Delta Z. Ah, never mind. Camera there, Z. There we go. I think we can simplify this here a bit. Ah, we also have. Oh, we already have a VOD here. Then how about we just put the pitch down here. Take VOD here. Okay, let's try this again. Okay, but it already looked pretty promising. It seems to work without glitching. That's good. For once, something works without bugs. Man, what a relief. I don't know how expensive this oversized terrain is. I'll take a look at this. So there's a init height data here, which probably does some allocation, right? Yeah, here it needs to reallocate. Oops, what happened now? Okay, I don't know why I can't enable the debug menu. There we go. Okay. Okay, so it does work. But it does cause some graphical glitching here for a frame. Yeah. Interesting. So it does work. But it does cause glitching. It's also quite laggy for moments. Okay, but we can look quite far then. Okay, that's good. Okay, but this is already a good start. We can work with that. Okay, what's up here with this shit? I see what the problem is. What do I think that the origin position to begin with is not correct. Hold on. Yeah, I think I'm stupid. Hold on. Oversized terrain. Yeah, the problem is that this function here changes the origin position. Yeah. Yeah. How can we avoid this problem? New org. Set draw org. Maybe. New org. Origin X. I think maybe we don't need this. New org. Delta. X. We should probably do the oversizing before. Yeah. So the question is, do we need this? Let's see what happens if we just compile this here out. Yeah. Okay, it doesn't glitch anymore, but it lags and it doesn't work anymore. Oof. Maybe it's lagging so hard because what is it doing now? Let's put a breakpoint here. It will not return. Why not? Get draw. Huh. 129. Oh, because we don't set this, that's why. TX. Okay, this looks promising, but there's still a glitch. The glitch is different now. Okay, I'm surprised by the performance degradation though. I wonder why that happens. I mean, I must be doing something really expensive then. What is it? This need full update. Is it this one that is so expensive? Can it hide data? Yeah, maybe. Oof, I'm copy. Okay, this looks expensive, yeah. It has to iterate over the whole map, and on each iteration it does some stuff here. Maybe this function can be optimized. Like, why is this temp buffer here always necessary? Why is it doing this? What is this? Temp. Delete. Default extra. Well, let's see, how often is this hit here? It's not hit. Okay. Okay, so it's not that. Let's put a breakpoint in here. Okay, some expensive stuff here. Okay, this doesn't look cheap. What is this? Yeah, it seems it has to do quite a bit of work there. Yeah. Yeah. Zero. Okay, it works, but it's extremely expensive for some reason. That's a bit worrying. Yeah, there's a really significant stall. Plus, there's a glitch. Yeah, the train is not rendered for a moment, but only part of it. It would be interesting to see this in a profiler. What is the slow there? Exactly. Okay, well, maybe we can first solve the graphical glitch. Yeah. I think this one also needs to go down here. Max. Yeah. Maybe, maybe this needs to happen even earlier. Yeah, what about we put it right here? By the way, there's a test here for map equals null return. And then here a test again for map. That doesn't make sense. That doesn't make sense at all. Let me remove that. Let's do it like this. Update center. Here we go, view tier. Normalized. How about we call this? Camera there. Let's call it look at vector. Here we do view the equals that look at vector. Okay. I at least want to get rid of this black flicker, which may be happening because of the terrain being the origin being incorrectly positioned for one frame, something like that. Still happens. Let's put a breakpoint here. So what happens now? Width heights. Width heights. Okay, there we go. Unit heights. Need full updates. Update center. Updating true. Then it will return. If updating. Will return here. Okay. Need full update false. Updating. It only happens when we go down. We need to figure out why that is. It looks suspicious that it goes in here and then it returns here. Yeah. Need full update. Updating. What does that mean, updating? Updating. Update. False, false. False. It's to avoid multiple calls, and I guess. So something can do recursive calls into this function, or? Okay. Boy, that's some weird design. That's some really shit design, yeah. Update block. Yeah, I think I will continue this investigation next session. I will end it here. Yeah, but I think it's an interesting direction. Now, the worrying part is that something is wrong for a frame and there's a huge performance spike, huge stall when it extends the locket area. So that's not nice. Yeah. Yeah. Need full updates. It kind of makes sense though that it does this here, right? Maybe we need to put that back. Yeah, let's put that back. The origin position is not in the center of the map. It's like at some top left coordinates, right? Yeah, so it does make sense. Yeah. TX. I see what it wants to do. It wants to relocate the origin position. Yeah, it's that makes sense. Somehow hotkeys don't work. There we go. Okay, that works. No, it does not. It still is flickering. Strange. But not always. Okay, I need some more investigation. What's going on there? Good. I will end it here. I think I was still a good session. I wish you a great day or night. Until next time, goodbye.